Alright, now we're getting to the good stuff. So, a little more higher level thinking questions. Number 1. Create a linear equation that's got a solution of a -4. So I give you the answer, you use a little bit of your creativity, come up with an equation that gives me that for a solution. It's got to be linear. So there's infinitely many different equations that will give you the same solution. Could be what number added to the number 2 will result in a -2. And the only solution that's going to make that satisfy that equation is -4. So you solve for x, -2, x equals -4. So there we go. That's one of many. Okay, the next one, create a quadratic equation that has a solution of -4. So same thing, but now it's got to be quadratic, and that one is a little bit tougher. Let's skip that for a sec. Let's come to this one. This guy right here. So this one, create a quadratic equation that's got solutions. So quadratic, there's always gonna be 2 solutions. If it is degree 2, there's always gonna be 2 solutions. If it's degree 1, if it's linear, there's gonna be 1 solution. So here we go. You got x equals 2 and x equals -3. So I don't think we've ever done this, but it's pretty easy. If I give you the solutions, you've got to work backwards and give me the equation. So here we go. If we work backwards, it's going to look like this. X. Okay, if my solution is a 2, if I plug a 2 in here, that means this has got to be subtracted 2. Because 2 minus 2 is 0. If this solution is a -3, that means this has to be a +3. So that means this equation right here, x squared plus 3x minus 2x minus 6 equals 0. That is x squared plus x minus 6 equals 0. This quadratic equation is the equation, there is one of infinitely many, that will give me this for the solution. So now, if it's got a solution of -4, it has it actually twice. This is called a double root. So x equals -4 and x equals -4. So if we start going backwards, we are going to go just like this. X, -4 is the solution, so this is going to be +4, this is going to be +4. Everybody give a warm welcome to Maverick for showing up to class. He wants the record to show that Lexi Writing gave him a ride. Oh, nope, she made him late. And the excuses are getting longer. Bottom line is, Maverick would like to earn your trust back by bringing everyone M&Ms to class next time. Alright, back to the math. So here we go. A double root of -4. That means it's going to be this. X squared plus 4x plus 4. It's a perfect square. All your perfect squares are going to be double roots. X squared plus 4x plus 4x plus 16 is 0. X squared plus 8x plus 16 is 0. This equation will give you a double root at a -4. Now, here's what that looks like. So if you're looking at the graph, here we go. So your solution is a -4 at level 0. So -4, 1, 2, 3, 4 is right there. Your parabola is going to look something like this. Your vertex, so this is kind of vertex form, x plus 4, that's x plus 4 squared. That is your vertex right there. This guy, Your solutions are at 2 and negative 3. That looks like this. One of them is at 2, and one of them is at negative 3. 1, 2, 3. We're not really sure where the vertex is. We do know that your A is positive, so it opens up like this. So your vertex, and we know the vertex has to be halfway between 2 and negative 3. 3, 4, 5. So 1, 2. So your vertex is like boom, 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 in between 0 and negative 1. So kind of halfway at negative 0.5. So somewhere there. And we're going to learn how to find the vertex of that later. But your parabola would look something like that maybe. Okay, the last one is kind of the same as the second one. So a quadratic equation that has a double root at the origin. So that means this. Your vertex is at 0, 0. So it could look like that, or I guess it could look like that. But your solution is 0 twice. Every quadratic's gonna have two solutions. They can be the same thing. That's called the double root. So here we go. X, x, and plus 0, plus 0. So, and this is called your parent quadratic. With no fancy business, no sliding left, right, up, down. If you park it at the origin, slope of 1. This is the grandfather of all quadratic equations, all parabolas. Okay, what about these two? What two real numbers multiply to create 16 and sum to a negative 10? So they multiply to 16, they sum to a negative 10, and they are negative 2 and negative 8. So x minus 2, x minus 8. That means the quadratic they come from would be x squared minus 10x plus 16. So these are the numbers. You factor them there. Minus 2 and a minus 8. But if it's an equation and we're trying to find the solutions and we set it equal to 0, then the solutions would actually be a positive 2 and a positive 8. So your solutions are kind of always opposite of what the numbers are. Okay, so here we go. Let's try the bottom one, which is going to be a million times harder. What two real numbers multiply to create a 16, but they sum to give you 4? 16, they add to give you 4. And you go through the factors of 16, 1 and a 16, 2 and an 8, 4 and a 4. And there's no way with these 6 integers that you can arrange them so that they add to give you 4. So your answers are not in the integers. They're still going to be in the reals. They could be rationals or irrationals. They could be something funky. But your polynomial is going to look like this. X squared. So they add to give you 4 plus 4x plus 16 equals 0. Now, I want the solutions. I'm going to find out what those two numbers are, but then I kind of got to work backwards and put them into the equation, the factor form of the equation. So here we go. It's not going to factor. I know there's no integers solution to this, so let's do quadratic formula. Quadratic formula is awesome. A, B, C. A is 1, B is a 4, C is a 16. So x equals negative b plus or minus the square root of b squared minus 4 times a times c. All of that divided by 2 times a. So here we go. Negative 4 plus or minus the square root of negative 48 all over 2. Okay, negative 48 is really close to 49. 49 is 7, so it's not a perfect square. It's going to be 6.9 something probably. Alright, let me erase some stuff. Okay, I guess I lied to you. Because this negative right here, if we take this negative out, that should be your first move. So it's going to be negative 4 plus or minus an imaginary square root of 48 over 2. So what two real numbers? There are none. There's no real number that will satisfy these conditions. But there's going to be an imaginary number that will. So we should have put complex. That would have covered all our bases. Could be real, could be imaginary, could be part real and part imaginary, which is complex. Okay, here we go. 48. Now let's bust up 48. Take all the squares out of 48. So 6 times 8, that's 2, done. 3, done. 2, 2, 2, done, done, done. So in 48, we have 2 squared, 3, 1. So 2 is out, 2 is out. So you have got to swap square root of 48. You're going to bring 2 2's out, so that's a 4 imaginary on the outside, 3 on the inside, and all that is divided by 2. Okay, now here we go. We are going to divide each of these guys by 2. So now I'm done, just about. So if we divide them each by 2, we're going to end up with a negative 2 plus or minus 2 imaginaries times the square root of 3. Alright, now these are the solutions. These are these. And these are opposite of the numbers we're looking for. So I want to know what numbers add to give you a 4 and times to give you a negative 16. So if I add these right here, if I add negative 2 plus 2 imaginary square root of 3, and I add it to a negative 2 minus 2 imaginary square roots of 3, these will zero out, and that will add to a negative 4. But I want them to add to a positive 4, so your solutions are kind of always opposite of that. So, opposite, if I times that by a negative, I just make it negative, that means it's going to be a positive 2 plus 2 imaginary square roots of 3. So if I make that positive opposite, it'll go negative, and if I make that negative opposite, it'll go positive. So I'm still going to have one of these that's going to be plus and one of them that's going to be minus. 2 plus, I already got the plus, so if we add them up, one of them's a plus, one of them's a minus. 2 minus 2 imaginary square roots of 3. If I add them up, that does give me 4. Paching. And if I times them together, it'll give me 16. So if I times this by 2 minus 2 imaginary square roots of 3, 2 times, 2 gives me 4. 2 times a minus that's a minus 4 imaginary square roots of 3. This times 2 is a positive 4 imaginary square roots of 3, and that is 0. And then 2 imaginaries times a negative 2 imaginaries. 2 times negative 2 is a negative 2, but I times I is a negative 1, and then square root of 3 times square root of 3 is square root of 9, which is the whole number 3. So I've got 4. A minus 2 times a minus 1 times 3 is it's 2 times 2 is not a minus 2, it's a minus 4. So there we go. So minus 4 times minus 1 is a positive 4. 4 times 3 is 12. 4 plus 12, that is giving me the 16. So that's it.